If you have ever stepped outside before sunrise and noticed a dazzling star hanging low near the horizon, you have already seen Venus. For centuries, it was called the morning star or the evening star, admired for its brilliance. To the naked eye, it looked like a beacon of calm beauty. But what lies beneath that glow is the most hostile surface in our solar system. Early astronomers once imagined Venus as a paradise, perhaps a jungle world with endless rainforests, or a planet covered in oceans hidden beneath its constant cloud cover. To many, it was Earth's twin, so similar in size and position that life seemed possible. That illusion shattered the moment we sent our first machines to investigate. Instead of rivers and green valleys, we found crushing atmospheric pressure over 90 times greater than Earth's, heat that can melt lead, and clouds made of sulfuric acid. Venus was not a second Eden, it was a furnace. This discovery changed the way we looked at our closest neighbor. Mars could be photographed from orbit, Jupiter's storms could be seen from afar, but Venus kept its secrets behind an impenetrable veil of clouds. To learn more, we couldn't just point a camera from space. We had to dive into that toxic atmosphere, risking every probe we built. And one by one, they were destroyed within minutes. The planet became known as Earth's twin with a darker side. A world that seemed familiar from afar, but revealed conditions far harsher and more extreme once explored up close. Hello and welcome. I'm Orion, coming to you from Infinite Universe NTH. The question that has haunted scientists ever since is simple. What did we actually see on that surface beneath the thick, choking atmosphere? The turning point came in December 1962, when the United States launched Mariner 2, the first spacecraft to successfully fly past Venus. At that time, many still believed the planet might hold oceans or lush vegetation hidden beneath its cloud cover. Science fiction magazines showed illustrations of swampy jungles or even civilizations. The truth, however, came as a shock. Mariner 2 carried no camera, but it carried sensors that told a far more powerful story. Its radiometers measured microwave and infrared emissions, and the numbers were undeniable. The surface was not mild or humid, but blistering, with temperatures soaring well above 800 degrees Fahrenheit, hotter than an oven. Atmospheric pressure was discovered to be nearly 20 times greater than Earth's, enough to crush a submarine hull. For some, the disappointment was sharp. The vision of a sister world full of life evaporated overnight. But for scientists like Carl Sagan, the discovery was a triumph of prediction. He had argued that Venus was suffering from a runaway greenhouse effect, where thick clouds of carbon dioxide trapped heat so effectively that the planet became a global furnace. Mariner 2 confirmed his theory and, in doing so, offered a cautionary tale for Earth itself. What happens to a planet when its atmosphere spirals out of balance? Venus became the extreme case study. Yet the hunger to see more did not fade. In the 1970s, NASA's Pioneer program took the next step. Pioneer Venus Orbiter and its companion probes pierced the veil of clouds with radar, slowly sketching the topography of the hidden world. What they revealed was not only strange, but unsettlingly familiar. A planet with mountain ranges higher than Everest, chasms deeper than the Grand Canyon, and lightning crackling through its dense skies. Pioneer transformed Venus from an abstract furnace into a landscape, still alien, but now mapped in detail. The dream of a green paradise was gone, replaced by the image of a rugged, hostile planet shaped by titanic forces. For anyone who grew up during the Cold War, this was a moment of revelation. Venus was no longer just a bright star on the morning horizon. It was a reminder that the universe held worlds where nature itself could be merciless. At the same time, it was proof of human persistence, our ability to reach across millions of miles and pull back knowledge. even when the answers were not what we hoped to hear. The illusions had collapsed, but a new curiosity had taken their place. If Venus was this violent, what would it take to actually survive a landing there? That question would soon lead to some of the boldest and most dangerous missions in the history of space exploration. If Venus had humbled American hopes with Mariner 2, it became the stage for one of the boldest campaigns in Soviet space history. Between 1961 and 1983, the Soviet Union launched nearly 30 spacecraft under the name Venera. Most failed. Some never left Earth's orbit. Others vanished into the dense clouds, crushed or burned within moments of arrival. But each attempt carried lessons, and step by painful step, the Soviets moved closer to the surface of a world that seemed determined to repel every visitor. The first real breakthrough came in 1970 with Venera 7. Unlike its predecessors, this probe was engineered like a miniature tank, built to withstand crushing pressures and searing heat. Even then, it barely made it. Its parachute failed during descent, and the craft plummeted onto the Venusian plains with a violent impact. Yet against all odds, it survived, just long enough to transmit a faint signal back to Earth. That weak radio pulse carried a stunning revelation. The surface of Venus was nearly 900 degrees Fahrenheit, hotter than molten lead. For the first time in history, data had been sent from the ground of another planet. The world was beginning to learn what hell actually looked like. But the Soviets were not satisfied. In 1975, Venera 9 delivered the first photographs from the surface of Venus. The images were black and white, half-panorama shots of a stony wasteland under a hazy horizon. For anyone who saw them, it was astonishing. We were looking at the ground of another planet for the first time. Yet the true spectacle was still to come. On March 1st, 1982, Venera 13 touched down. Its landing site was bleak and fractured, scattered with dark rocks and fine, grainy soil. But this time, the lander's cameras worked perfectly. For 127 minutes, a record that has never been broken, it sent back full-color images from the Venusian surface. What came across the radio waves was surreal. The sky appeared a sickly yellow, as though perpetual twilight had settled over the landscape. The ground was flat but broken, with slabs of rock that looked both alien and strangely familiar, like volcanic fields on Earth twisted into something more sinister. Viewers back on Earth could hardly believe it. We were not just imagining Venus anymore, we were standing in its toxic silence, seeing with our own eyes. And then came something even more eerie. Venera 13 and its twin, Venera 14, carried microphones. In those last minutes before the planet silenced them, they captured the first sounds ever heard from another world. The recordings revealed a faint hum, mechanical noises from the lander, a low rush of background static, and, most haunting of all, the whisper of wind moving at less than 1 mile per hour. On a planet with an atmosphere thick enough to crush steel, the wind at the surface was calm, almost peaceful. The contrast was chilling. In the middle of a furnace, beneath clouds of acid, with temperatures hotter than any desert on Earth, Venus whispered rather than roared. For the scientists listening, every minute felt like a miracle. They knew the craft could fail at any second, that its electronics were slowly cooking. And then, after 2 hours and 7 minutes, the signal ended. Although Venera 13 eventually fell silent, its mission delivered a legacy unmatched in space exploration. The first color photographs of Venus, the first sound recordings from another planet, and an extraordinary view of a world both familiar and alien. It was not just data, it was a message. Venus, the bright star of our mornings and evenings, had finally revealed its face. And what we saw was not comforting. It was a reminder that the universe can shape worlds both beautiful and brutal, and that survival, even for a machine, is a fleeting miracle there. The images from the Venera landers were unforgettable, but they were snapshots, fragments of a much larger world still hidden behind endless clouds. To truly understand Venus, humanity needed to see it in full, to chart its mountains, plains, and valleys the way we had mapped Earth. In 1989, the United States returned to the challenge with a spacecraft that would change everything: Magellan. Unlike its predecessors, Magellan carried no traditional camera. Instead, it was armed with advanced radar, capable of piercing through Venus's dense atmosphere and bouncing signals off the surface. Over the course of 4 years, orbit after orbit, Magellan built the first global map of Venus with astonishing clarity. What emerged was both beautiful and unsettling. Vast volcanic plains that stretched for thousands of miles, towering mountains that dwarfed Earth's Everest, and canyons plunging deeper than the Grand Canyon. For the first time, we could see the scale of Venusian geology, and it was extraordinary. Among the discoveries was Maxwell Montes, the highest peak on Venus, rising more than 11 kilometers above the surrounding plains. Nearby lay Mat Mons, one of the largest volcanoes in the solar system. A reminder that Venus is not a dead planet, but one shaped by restless forces. And then came perhaps the most surprising revelation: evidence of tectonic activity, fractures and flows across the landscape, suggesting the planet was not static, but alive with motion. For scientists, this was a revelation. Venus was not just a scorched ball of rock, but a dynamic world with its own dramatic history written in stone. 2 decades later, Europe added a new chapter with the Venus Express mission. Launched in 2005, it did not land but orbited for years, studying the atmosphere in exquisite detail. One of its most remarkable discoveries was the presence of enormous vortices at the poles, hurricane-like structures with 2 giant eyes, twisting and shifting unpredictably. Unlike Earth's steady jet streams, Venus's polar storms were unstable, morphing in shape and even disappearing over time. It was another reminder that Venus is a planet of surprises, refusing to fit neatly into our expectations. For anyone watching these missions unfold, the sense was clear. Every probe, every radar sweep, every unexpected discovery peeled back one more layer of mystery. Venus was no longer just Earth's evil twin or a symbol of failure. It was a living laboratory, a place where the laws of physics and the extremes of nature played out on a scale far beyond anything we knew at home. And through the determination of human ingenuity, whether Soviet, American, or European, we had turned the unknown into knowledge. From the first blurry images to global maps and swirling polar storms, Venus was revealing itself. And yet, with every answer came new questions. How did a world so similar to Earth take such a different path? Could it once have been habitable? And perhaps most important of all, what lessons does its fate hold for us? So far, our journey through time and space has revealed a planet more hostile than hopeful. But the story of Venus is far from over. In the coming decade, humanity plans to return, armed with better tools and higher ambition than ever before. 2 NASA missions, DAVINCI Plus and VERITAS, now stand at the forefront of this renaissance in Venus exploration. DAVINCI Plus, Deep Atmosphere, Venus investigation of noble gases, chemistry, and imaging, will dive through the thick Venusian atmosphere, from cloud tops to the surface, measuring gases, isotopes, and chemistry as it falls. It aims to capture the first high-resolution images of Venus's rugged highland terrain, regions that may preserve the oldest clues to the planet's history. During its descent, the probe will sample pressure, temperature, and winds at multiple layers, building the most detailed atmospheric profile ever attempted. And if it survives long enough to touch the ground, even a few minutes of data would be priceless. VERITAS, meanwhile, will orbit Venus to build a new, ultra-high-resolution radar map. Using advanced imaging, it will resolve features down to unprecedented detail, giving us fresh insight into volcanoes, tectonic activity, and perhaps even evidence that the planet is still geologically alive today. The mission promises to create a three-dimensional view of Venus that will finally reveal how its surface has changed over time. Beyond NASA, Russia has proposed Venera D, a lander and orbiter designed to survive hours on the surface, something no mission has ever achieved. Europe is planning Envision, a powerful orbiter that will study the planet's geology and atmosphere in the 2030s. India is preparing its first mission to Venus, Shukrayan-1, to add yet another perspective. Together, these efforts mark what many call a new decade of Venus. Imagine a day when we receive full-color panoramas from the highlands or detect gases that hint at ancient oceans and volcanic eruptions. These are not fantasies. They are the goals scientists are preparing for right now. If Venus once had water, or even conditions that supported life, its history is waiting there, buried under clouds and crushing pressure. But Venus is not just a world of curiosity, it is also a warning. Its runaway greenhouse effect and hostile climate show us what happens when a planet tips past the point of balance. As we prepare to return, every measurement we take is more than science. It is a mirror held up to Earth's own fragile future. That brilliant star you see at dawn and dusk is no star at all, but Venus. In just a few years, our spacecraft will descend through its clouds once again, and what they discover may finally tell us how a world so much like Earth became so utterly different. Thank you for joining me on this journey. I'm Orion, and this is Infinite Universe NTH.